Hello, I'm about to start the lesson. Hi mathematicians, I'm Mr. Beebe, and I'm so glad you're here. Today we're going to solve a math mystery together. But before we get started, I have a question for you. Imagine you and a friend each ordered a pizza. You ate 3/8 of your pizza and your friend ate 2/3 of theirs. Sorry, 2/4 of theirs. Who ate more? Take a few seconds to think about it. You might be tempted to guess, but mathematicians don't guess. They use strategies to prove their thinking. Today, I'm going to show you a simple strategy that will help you compare fractions by using a benchmark fraction called 1/2. By the end of today's lesson, you'll be able to compare fractions and explain why your answer is correct. Let's start with today's learning goal. Our target is I can compare fractions using 1/2 as a benchmark and explain my thinking. Today we're going to think and talk like mathematicians, so we'll use words like numerator, denominator, benchmark fraction, greater than, and less than. We'll be able to compare fractions to 1/2 and use greater than and equal than signs and symbols and be able to explain our thinking. As we move forward, try using those words when you explain your thinking. Here are the math words we're going to use today. This is some important vocabulary: numerator, denominator, benchmark fraction, compare, greater than, less than, and finally equal to. Let's jump right in. The numerator is the top number in a fraction. It tells us how many parts we're talking about. The denominator is the bottom number. It tells us how many equal parts make up the whole. Our benchmark fraction today is 1/2. A benchmark is a fraction we already know well, and we can use it to compare other fractions. Compare is evaluating if one is greater than or less than another. Greater than means that the value is larger than another value. Less than means that a value is smaller than the other value. And equals means that both values are the same. As mathematicians, we will use these words because they help us explain our thinking clearly. Are there any questions? Okay, so before we can compare fractions, we need to know what our whole looks like. The whole is the entire piece of whatever we are examining. In front of you is a bar. This bar is the whole and represents 1. Here you can see I added another bar below the whole that we just looked at. I also added a line to the middle of the bar. Can someone tell me how many pieces make up the whole of the second bar? Great, that's right, 2. Now if I add the color orange to one slide of the second bar, how much of the bar is covered in orange? That's right, 1/2. This is our benchmark fraction, 1/2. We know exactly where 1/2 is, so we'll use it to compare other fractions. Now I added a third bar, and I divided it into 8 pieces. I then added orange to 3 of the pieces. Does anyone know how much of the last bar has orange added? Great, 3/8. What do you notice in relation to the 1/2 bar? That's right, it's smaller or less than 1/2. Okay, hang on to your seats. This is where we're going to have some fun. Now we're going to try some together. There are 2 fractions on the page, 5/8 and 1/4. We're going to try and see if these fractions are greater than or less than 1/2. The first fraction is 5/8. The second fraction is 1/4. Are these fractions greater than or less than 1/2? When you're ready, explain your thinking using this sentence frame. I know blank is greater than or less than 1/2 because... Okay, let's check together. I added orange to fill in the squares to help us represent the fractions 5/8 and 1/4. Let's remember our benchmark fraction of 1/2. That is, 1/2 is half of the whole. We can see by the covered orange sections that 5/8 is greater than 1/2 because it goes beyond halfway. We also know that 1/4 is less than 1/2 because it doesn't reach halfway. Did your explanation sound like a mathematician? Now, let's represent fractions on a number line. But before we do that, please look at the bar on the screen and the numbers within the bar. What do you notice? The fractions to the left of the 1/2 are smaller than the fractions on the right side. 8 out of 8, 8/8, or 1. This number helps us see the size of each fraction. Question for the class. Why do mathematicians use number lines? That's right, because pictures help us understand where numbers belong before we move to symbols. Okay, I think some practice together would be great and beneficial. So let's represent some fractions on a number line. The first one is 1/4, then 3/4, then 1/2, and finally 3/8. We'll fill these in with orange to represent the fractions. Okay, I added orange to the boxes to represent the fractions that we just talked about. Now let's look at these another way. Instead of using a fraction bar, we're going to compare them by looking at how much of the whole is shaded. Remember to ask yourself, what do I notice, and how does this compare to 1/2? Let's start with 1/4. What do you notice? Only one of the 4 equal parts is shaded. Is 1/4 greater than or less than 1/2? It's less than half because it doesn't reach the halfway mark of the bar. Now if we look at 3/4. 3 out of 4 equal parts are shaded. Is 3/4 greater than or less than 1/2? It's greater than half because more than half of the whole is shaded. We'll jump down to the bottom now and look at 3/8. There are 3 equal parts of the 8 equal parts shaded. Even though the denominator is larger than the shaded part, it's still less than 1/2. How do you know? Because it doesn't reach halfway across the whole. Now we're ready for the abstract part. We're going to learn about and how to use mathematical symbols. We want to know which fraction is bigger. We will use math symbols to show our thinking. We can recall from earlier in the lesson that 3/8 is less than 1/2. The symbol in between the two fractions represents that fact. We'll call this symbol the alligator jaws eating the bigger fraction. Since 3/4 is greater than 1/2 and 3/8 is less than 1/2, 3/4 is greater than 1/2, we know that 3/8 is less than 3/4. Can you prove it? Think about everything we've seen. We've used fraction bars, we've used a number line, and now we're using symbols. All 3 of these representations tell us the same mathematical story. Does anyone have any questions? Okay, now it's going to be your turn to be the mathematician. As you work, don't just think about the answer. Ask yourself, what do you notice? What do I know? And can I explain my thinking using today's new math vocabulary? The first one is 1/4 being compared to 3/4. Which is larger? Second, 3/5 versus 2/5. Which is larger? And finally, 5/6 versus 1/2. Which is larger? I've added some bar charts on the right-hand side of the page to help. Okay, we can see that 1/4 is less than 3/4 looking at the bar chart, because 1/4 has less of the whole shaded than 3/4. We also see that 3/5 is greater than 2/5. Since both fractions have the same denominator, we compare the numerators. 3 is greater than 2, so 3/5 is greater. And now the last one, 5/6 is greater than 1/2. 5/6 is more than half of the whole, so it's greater than 1/2. Nice work. Remember, mathematicians don't just find answers, they explain why their answers make sense. Today you learned how to compare fractions using 1/2 as a benchmark. More importantly, you explained your thinking using mathematical language. Remember, mathematicians don't just find answers, they ask questions, they look for patterns, and they explain their reasoning. The next time you compare fractions, ask yourself if this fraction is less than 1/2 or greater than 1/2, or is it exactly 1/2? If you can answer that question and explain why, you're thinking like a mathematician. Great work today. I'll see you in your next class.